In this one, we're going to look at a BGW750C. This is a big-ass power amplifier, 200 watts per channel in stereo mode, but up to 750 watts of ass-kicking power in bridged mono mode. These things were monsters. They were used in movie theaters, in other professional applications. This one's dead. Let's see what went wrong with it. So the client who owns this one said he was hooking it up, and he plugged an input plug in with the power on, and it went pop. He doesn't know what might be wrong with it, so we're going to check it out. There might not be anything wrong with this unit, but again, it may be blown up. So let's find out. Now, this one being the beast that it is, I can't very well plug this into my isolation transformer because it's going to draw far in excess of the 3 amp fuse that's protecting my Variac and isolation transformer. And it'll probably also draw in excess of the current that my power bar, because my power bar seems to be on its last legs as it is. So I'm going to power this one up directly from a separate circuit once I get it connected. I'm not going to connect it to speakers initially. I'm going to look and see if there's any DC voltage coming out the speaker terminals when I power it up. So first things first, throw the power switch on. One might even see the lights flicker a bit when I turn this thing on. And we did. It's on the same circuit as my lights. We'll just check for any DC voltage, which there's none, which is good. When I turn it off, do we get any DC voltage as this thing's powering down or powering up? No. So that's a good sign. Next, I'll connect a couple speakers, and then I'm going to have to give it an input source. Now, this has got both unbalanced and balanced inputs. I don't have a balanced source to feed it, so I'm going to feed it through 1/4-inch phone plugs. And probably have to do that one channel at a time. We'll see what I've got for 1/4-inch plugs. I might have a pair of them that I can make up a temporary type input, and we'll feed it with the MP3 player. Turned down, obviously, all the way, because this needs a preamp to drive it, so I'll drive it with a variable output from my MP3 player. There may not be anything wrong with this thing, so this might be a pretty short video, but I thought this was kind of a cool amplifier, so we'd film the checkout on this thing. Okay, I've got it all hooked up. Before I throw the switch, I got the volume set to 1 on this, by the way. Before I throw the switch, I give you guys a little bit of history. I've learned about BGW amplifiers. Back in the 1970s, that's when these came out. These were built. There was lots of these things built. There was lots of them that ended up on the surplus market, dirt cheap. I learned this from a guy that I used to work with. His dad was in the movie theater business, and in the 1970s, a movie came out called Earthquake. Prior to Earthquake, most movie theaters had one speaker behind the screen. You might have been lucky and had a stereo theater, but nobody had ever heard of surround sound prior to that. And Earthquake kicked it up, not only to surround sound, but they kicked it up a notch. They called it in-sense surround, and they actually had shakers attached to the seats to shake the seats. And for that sound effect, for the subwoofers and the seat shakers, they had stacks of these amplifiers that were built basically for the movie theaters for the run of Earthquake. And my buddy I worked with, he was telling me that after, when his dad was still in the business, he was down at a warehouse, and they had, because after the movie finished its run, they pulled all the equipment out. They pulled the seats out, they pulled all the amps out, and they had them all stacked in a warehouse. And my buddy, who's a stereo guy now, right? He's got some nice amps and stuff, but he's kicking himself because he could have bought a stack of these amplifiers for like a couple $100 a piece. So they were literally giving these things away. They had them, they were all custom made for the movie theaters. A lot of them were anyway. A lot of these were, they had built a ton of them that were used for the debut of Earthquake back in, was it 73, somewhere in there when that movie came out. Anyway, they had tons of these things built that were built specifically for the theater. And after the movie finished running, They took all the equipment out. It was put in a warehouse, probably with the thought that if another movie came out that needed it, they could reinstall it. But after that movie, they never reinstalled it. All the theaters went to surround sound, and they never put in the massive subwoofers and the seat shakers that they had used for Earthquake. So they didn't need all these big powerhouses. These amplifiers would typically put out about 230 or so watts per channel in stereo mode, but if they were bridged into mono, you would connect just to the two positive speakers and use, I think it's just the left input. You use just the two red terminals for speaker positive, speaker negative, and then you would get 750 watts of power. And that's what they would run these in when they were running them in the theaters. They would run them into big, huge speakers and basically actuators on the chairs to shake the chairs, and they fed them with these. Anyway, that's a little bit of history about a lot of these amplifiers. A lot of the BGWs were used for that. So there was tons of them around. They all sold dirt cheap, and now these things command quite a small fortune. Let's turn this one on and wish me luck. See if we get any sound. Okay, volume. I think that's volume. Or is it this one? I don't hear any sound. We should have music. So something is wrong. So let's pop it apart and see what is wrong. Two monoblock design. To check the cutouts here and see if any of those are open. So none of the cutouts are open. Check for voltage. So these are a relatively high voltage amplifier. When I say relatively high voltage amplifier, I mean it. 155 volts is the rail voltage. So in other words, these have enough energy to really give you a good jolt. And yes, if you were to touch across both the collectors, you would receive a severe shock. This does have enough energy in it to actually kill you. There's enough energy here. If I were to touch across both of these terminals with my bare fingers, with it energized, there's enough power stored in this thing that would stop my heart, just like that. So these amplifiers command respect when you're working on them. Also, the fact that you've got 155 volts difference between the positive and the negative means that you could have upwards of 155 volts to the speaker terminals. So they can produce a very high voltage, and as I say, they can evaporate your speakers, the voice coil in your speakers, in an instant if something were to fail. But there is no DC voltage here. I don't believe there's any shorts on here. We're not getting any sound though, so that's where we have to investigate. Unplug this thing, and I gotta let the capacitors drain out on this thing because they will hold a voltage for a couple of minutes, not long. You'll see that the voltage actually drops off pretty quick. As you can see, it's down to 26 volts. I mean, I'm getting negative there just because that's the polarity I used. This is the positive side. This is the negative bank. So I'm going to remove one of the amp boards. Take a look underneath it. It's odd that I'm not getting sound out of either. Oh, somebody put a slotted screw in there. It's odd that I'm not getting sound out of either channels when this is a monoblock design. I had this amp a couple of years ago. This is the one that we changed the fan on. It had the really noisy fan, and I put a little power supply in to run a low voltage computer fan because the fan was making such a racket. It was driving the customer crazy. Oh, that's why. There is a protection relay in this one. So here's our amp. There is a relay here that cuts off the sound. Well, that would explain why there's no sound. A lot of these amps did not have protection. One thing I should be able to do is I should be able to unplug a power board and power the unit up and see whether the relay cuts in, and we'll do the same on the other. That way, if it's a fault that's being detected on one of the amplifiers, we can isolate which one's causing it. It should, anyway. It should turn on with only one board connected. We'll just make sure this other board is not anywhere where it can touch anything and short anything out. Maybe set it up like that. And we'll see whether the relay kicks in. I've got my speakers disconnected now just so that I don't have to worry about popping anything. But I want to see if that relay is going to kick in. Okay, relay's not kicking in. I'll just let the capacitors completely discharge before I connect this amp board, and we'll disconnect the other one and see whether that will bring the relay back. Okay, we'll try it with the other amp disconnected. Trip the breaker. No, I don't think that that's something in the amp that's causing that. That's just my weak breaker. It quite often trips when the vacuum gets plugged in too. There. Relay kicked in, you heard it, listen. There, see? The relay's kicked in. So the problem's on this channel. This one's got a fault. Easy way to isolate. If I connect up sound to the speaker that's working, I should have sound. Whichever one was working. I don't remember which one it was, so I should have sound playing through it now. So one channel's working, this one's not. Shut it off. So we know the fault's on here, so now I've got to troubleshoot this amp board, and hopefully it's not an obsolete part that's popped, because this thing's got parts on it that it just cannot get, such as these ICs, these early ICs. Good luck trying to find those. They are parts that will be difficult to find. All the parts on here are pretty much obsolete. These transistors probably wouldn't have much luck finding them either, but let's go through and measure and see if I can find some shorted parts. Let's measure outputs first. Emitter to base. 0.8. I may have to disconnect these. I may have to disconnect some of these. They're all measuring shorted. It could be that they're all shorted, but I may just have to disconnect the leads here just because of internal loading between other components. Can certainly give me bad readings in circuit. Driver looks okay. That one looks okay. Yeah, those transistors look probably okay. But I'm going to disconnect. I'm just going to disconnect the pin on these outputs, and we'll measure them disconnected, as I'm getting shorts across all of them, which shouldn't be seeing. But fortunately, all I have to do is just either disconnect one leg or disconnect the emitter resistor here. Probably easier just to disconnect the emitter resistors, and then I should be able to measure between base and emitter. Let's see if I've got any shorts. So I'm just waiting for my little cheap iron to warm up here. Okay, emitter base has been disconnected. Oh, that one's not disconnected yet, but we'll check these other ones. Emitter base, okay, we'll check that one. Looks good. No short, no short, no short, no short, no short there, and then base to collector. It's good. Base to collector. And emitter collector should be open. That one's still connected. Yeah, that one's not blown either. So all those transistors are good. We'll do the same for the ones on the other side. I doubt it's the output transistors. I seriously do doubt it's the output transistors, but we have to start somewhere. It's more than likely that, because what happened was he had the amplifier powered up when he unplugged one of the 1/4-inch plugs on the back here. He had it powered up when he pulled out one of the plugs, and he said there was a loud pop and it went dead. In all likelihood, he blew the preamp, which is that special obsolete part. So we may not be able to fix this one, but we'll see. I hope it's not that part. I actually have a couple. I have some of these. I don't know if I've got the right one, but I have a box full of old oddball transistors. So I might even have one of these. I'd have to look up the number, but let's measure the other ones and see if there's any shorts. You see if the one of the drivers went bad and it was supplying a DC voltage, it would be a DC voltage detected by the protection board, and it would keep the speakers off. Good, 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 good. And this one will measure short. Nope, doesn't. Oh, it does, yeah, because I got it disconnected. But we'll measure base to collector. Okay, base to collector, base to collector, base to collector, base to collector, and base to collector. That's good, right? And then if I go emitter to collector, will be open. We're over here. That should be open. We got a resistor across here on that one. So everything disconnected, all the outputs are testing good. I haven't tested the emitter to collector on this side yet, but I'm sure that they're okay. I gotta disconnect that one, that resistor. There's no shorts, that's for sure. That's what we're looking for, is shorts. The output transistors are all fine. Here's a print for the amplifier section. As you can see, the outputs here, there are 5 outputs. Actually, there's 6 transistors, but there's 5 output transistors per channel that are all connected in parallel with each other. The first stage, this one here, the SJ7407,
an FJ, whatever that is, a 1394, I think it is. The PNP and the NPN. These are the drivers here. So this is the first transistor, the one I had to disconnect separately. It drives the bases. They're all driven in parallel for the remaining 5. Same with this one here. These are driven from the drivers. The drivers are driven from the op amp. Over here, the preamp. The LM318, I think it is. Hard to read there, but it looks like LM318. That's the one. That's the part that I'm concerned that might be damaged. As you see, the signal comes in directly through here, goes through a capacitor, and then directly into pin number 2. Signal goes in. We'll have our dual power supply feeding through R5 and feeding through R7. Either one of these could be open. That will certainly cause a problem. We'll check that. There should be plus 10 volts and minus 10 volts to pin 7 and pin 4 respectively for this op amp. If we were to lose either one of those voltages, such as if a resistor went open or one of these Zener diodes that regulate the voltage were to short, that would give us an offset here, which would throw the whole thing out of balance. So, you know, providing, hopefully this chip is not bad, because I don't have one. Let's check these Zener diodes out, CR1 and CR2, and see if there's any shorts, first of all. Gotta love this way of building an amp, too. Just solder all the components on the, there's nothing on the other side of the board, right? Everything's soldered to the surface. There's no through hole. That board is mounted right down to the heatsink. It's a single-sided board, and everything is just soldered onto the surface. So we can check the Zener diodes here, see if they're shot. That one looks okay, no shorts there. No shorts there. We'll check the 2 resistors, which are feeding into pin 7 and pin 4. R7 and R5, they're 3.9K resistors at 2 watts, so they're going to be big ones. They're not going to be open. There's no way that they're going to be open. Okay, 4K, close enough. Also well within specs. So those 2 are okay as well. I guess the thing now to do is to plug this thing in, power it up, and make some measurements. Another Zener diode. I think this is a Zener over here. Nothing shorting there. To keep everything safe while I'm working on this thing live, I'm going to put this on a rubber or silicone mat, just so that nothing is going to short anything out. This side here is live. I got to keep my fingers away from this. I'll put something over top of this one as well. Well, I'll just be careful. Yeah, I'll remove my watch when I'm working on this because this is high voltage, but I'm basically going to be measuring between ground and a couple different points on here, looking for my 10 volt supply, 10 volts and 10 volts, and then we'll look at the output. I'm going to disconnect my speakers so I don't have to worry about having anything come on loud and scare the crap out of me while I'm working on this thing. And we'll power it up and chase some electron. Okay, let's plug this thing in. What the hell? I just heard the relay click. Isn't that strange? Minus 10. So our voltages are there. I just heard that relay click like this thing's working. I wonder if it just needed to come apart and have the plug taken out and pushed back in. Let's see if we get sound.
Okay, I'm probably going to get a copyright match on this. This song that just happens to be playing is called EKG by the Music Bakery. And I licensed this track years and years ago. I've used it many times and I'm getting all these hits on it now. Because some guy came out, a guy named Scott Shannon, took the music. You can look him up. It's called Come Away by Scott Shannon.
He's slowed down the tempo and he's posted it, and I'm now getting hit with this, and I have to dispute it. So I'm going to talk over this because I don't want to get hit.
I've done nothing to this unit other than I unplugged both plugs one at a time, plugged them back in, and when I unplugged this plug, nothing happened. The relay did not kick in. When I unplugged this one, the relay kicked in. I tested the transistors to see if there was any that were shorted. There were none. I checked my Zener diodes to make sure there's no shorts. There were none. I'm just going to set up to do voltage measurements. I plug the thing back in and the bloody thing starts working. So either we have a bad connection somewhere, which is possible, or it was the plug wasn't seated properly. I guess what I'm going to do is I'm just going to inspect these connections down here on things like these driver transistors. Maybe we'll look at them closely, and I'll look for connection problems, because it's certainly proven itself it's not a component that's failed. The stupid thing's working. Kind of love these things like this when this happens. But hey, the guy that owns it will be happy, that's for sure, that it's working again. I just don't know why it cut out like that, because it certainly was in protection mode. Again, it could have just been a coincidence, and it could have been one of the connection wasn't seated properly. But it certainly is operating now. We'll just make sure that the voltage is discharged, and then I'm going to touch up these driver transistors. I'll do it on both boards, because if one's bad, the other one probably isn't far behind it. We're down at 5 volts now. We'll just give this thing a minute or so for all the voltage to drain out, and I'll unplug them as well when I do this, so that there's no power at all. Right, everything's dead. So I'm just going to go over. I'm going to go over the driver transistors, and that's about it. I don't think anything else needs to be taken care of. I'm just looking at some of these connections here, and they look like they might be just a little bit. Some of them look a bit flaky, so we're going to go over those, reheat those ones. I'll do it on both boards, and we'll call this one a day. And you know, when you hear people talking about doing a cap job, well, a cap job on this would be 3 electrolytic capacitors on each side, so a total of 6 caps. And if you really want to spend a lot of money, the great big monstrous electrolytics. But there's not a heck of a lot to change on these. They're pretty simple design. Not quite direct coupled. Direct coupled would have no caps in them at all, no electrolytics at all in them, but and no coupling caps. These ones here are all coupling capacitors, but the ceramic and these orange dip ones typically don't fail as a rule. Anyway, I resoldered the driver transistors on this board. There's my little power supply I put in for that low voltage fan. This is the one that I had a couple of years ago. I forget, maybe 5 years ago. I forget when I had this, but it was a while back. But anyway, that side is done. I'm just going to do the same on this side.
And then we're going to close this one back up. One last test before the screws go into it. Looks like it's working. Weird. You get weird problems like this. I mean, it certainly wasn't working when I first plugged it in, and now it is. So, don't know what caused it, but as long as it's working, there's not a heck of a lot I can do to troubleshoot anything else, because any tests I do on it are going to be, you know, they're going to be good tests. Unless I can recreate the fault and make it fail, there's not a heck of a lot I can do as far as testing. Transistors measure good. The only thing I can think of that may have caused that fault is the it's maybe one of the connectors. Okay, top cover.
You know, in '78 these weren't that big a deal, but these days these amps are quite sought after.
And there's nothing really that special about them, other than the fact they got a great big power transfer in them. They got big power, but they're just a standard class AB. I mean, you look at the schematic, and they're probably one of the simplest circuit diagrams that you're ever going to see. It's real simple. I mean, there are many more amplifiers that are much more complex than this. Op-amp IC, a couple drivers, some temperature compensation for the bias, and parallel output transistors for a big power. Not the cleanest in the world, for sure. I think the distortion on this is, what is it, 0.2? It says right on the top here. 0.1%. So, 0.2 if you're running it. Well, if you're running it at 4 ohms, it's 0.2. So it's not, certainly not the cleanest, because there are amplifiers out there that are much cleaner, like my Technics. Saw a pixel there, but it's my screen. My Technics SUV9, for example, has, I think it's 0.03 distortion on it, 120 watts per channel. This is 200 watts per channel. You know, it's 0.03. This is 0.1. So 0.1 and 0.2 if you're running it in bridge mode. That's a heck of a lot higher distortion than 0.03. But power-wise, these things are brutes. There it is. Okay, it's working. Can't do much more on it. Thanks for watching.